One of the challenging lessons in mathematics is the application of concepts to real life, particularly if you are solving a problem involving them. And as a math teacher for a decade, practice and exposure to many problems, including the different techniques in solving them, will really help us develop the skill. So just stick around and I will teach you how to learn this lesson in an easy way. And if you are not a subscriber yet, don't forget to hit the subscribe button and the notification bell so that you will be updated every time I will upload new math videos made easy for you. Application of rational algebraic expression or word problem. In order for us to solve problems that involves rational expression, or we call it rational equation, we have to bear in mind with these following steps. So first, if you're dealing with fraction in either of the sides or both sides of the equation, so we have to get rid of the denominators. So to do that, we have to multiply both sides of the equation by the LCD. Then after which, you are going to solve that equation, and in solving, we have to make sure to observe the different properties of equality so that we are certain that our solution is correct. Let's have example number 1. There are two numbers whose sum is 48. One number is 1/3 of the other. So what are the two numbers? We have to solve this problem using the same method, which is the Polias method, in which first step you are going to understand the problem. This problem is asking for the two numbers, and we will now let the first number with the x. Then according to the second condition, that the other number is 1/3 of the other. So if x is the first number, so to represent the second number is 1/3 of x. So devise a plan. We are going to translate the given situation to make an equation. So according to the statement, the sum of the two numbers is 48. So first number plus the second number is equal to 48. So is equal, then copy is 48. So since our first number is represented by x plus the second number represented by 1/3 of x, or x over 3, and that would be equal to 48. Now, this is now the resulting equation given the condition of the problem. In step number 3, in Polias method, we are going now to solve the problem. So, x plus x over 3 is equal to 48. According to the step that I had showed earlier, that to solve problem that involve fraction, we have to get rid of the denominator. To do that, we have to multiply both sides of the equation by the LCD, which is 3. So distribute 3. So 3 times x, then plus 3 times x over 3. Then that is equal to 3 times 48. Simplify. So 3 times x is 3x. So 3 times x over 3. So that would be x alone. Then is equal to 3 times 48. That is 144. So solve this equation. So 3x plus x is equal to 4x. We just copy 144. So by virtue of the division property of equality, so we have to divide both sides of the equation by positive 4. So 4x divided by 4 would be x. Then 144 divided by 4 is 36. Therefore, the value of x is equal to 36. How do we know that this value is correct? So we have to check. So according to the condition of the problem, first number plus the second number must be equal to 48. So if x is our first number, substitute x. So 36 divided by 3, so that would be 12, and 36 plus 12 would be 48. So as we all knew, that first number plus the second number, the sum is 48. So therefore, the condition is satisfied. In this case, the first number, which is x, would be 36. The second number represented by x over 3, or 1/3 over x, that would be 12. So these are the two numbers. Example number 2. Think of a number, double a number, then subtract 6 from the result and divide the answer by 2. Then the quotient will be 20. Then what is that number? So since the problem is asking for a number, in this case, we will take x to represent that number. So if x is the number, so we will make an equation based on the given condition. So second statement, it says here that we're going to double a number. So to double a number, if the number is x, to double it, we have to multiply it by 2. So this is the representation of the double a number. Then subtract 6 from the result. So if after doubling the number, the result is 2x, then subtract 6 from the result. So that would be represented by 2x minus 6 as the expression. Then after which, divide that number by 2 and the quotient would be 20. In the third step, if we are going to divide this number by 2, so this expression would represent that statement. And the quotient will be 20, so that would be equated to 20 because dividing two number, quotient would be the answer, and the answer would be 20. So we have now the equation. So solve this equation. So again, there is a denominator. So to get rid of this denominator, we have to multiply both sides of the equation by the LCD. In this case, 2. So distribute 2. So 2 times this left side of the equation, 2x minus 6 all over 2. Then that is equal to 2 times 20. So 2 will be cancelled out. So what is left in the left side of the denominator is just 2x minus 6. Then that is equal to 2 times 20 would be 40. So in this case, the left side of the equation consists of two terms. So we have to get rid of negative 6. To make it 0, we have to follow the addition property of equality. In a simplest form, we call it a transpose. So we have to transpose negative 6 to the other side. That is why it becomes positive 6. So 2x plus 40 plus 6, that would be 46, and divide it by 2. So therefore, our x is 23. So how do we know that this is correct? So again, we have to check. So the given equation is 2x minus 6 divided by 2. That would be 20. So our x is 23. Substitute. So 2 times 23. Instead of writing x, change it to 23. Then copy negative 6. Copy positive 2. Then copy 20. So further simplification, 2 times 23 is 46. Then minus 6 divided by 2 is equal to 20. So 46 minus 6 is 40 divided by 2, and that is 20, and that is equal to 20. So since the condition is satisfied, therefore the number that we are looking for is 23. So third problem. 3 years ago, Theodore's age is one half of the age he will be in 6 years. So how old is he now? So the problem is asking for the present age of Theodore. So x, to represent the present age of Theodore, you can solve in any method, but for this case, I will be using table to solve this particular problem. This is the present age. So to represent the present age of Theodore, that would be x. If this is the age of Theodore now, so to represent his age 3 years ago, we will subtract 3 to x. So that would be x minus 3. Then after 6 years, how are we going to represent his age? So if the present age is x, so after 6 years, we will add 6 to x. So these are the representations of the given condition stated in the problem. So we will now make an equation. So according to the problem, age of Theodore 3 years ago is equal to one half of the age of Theodore 6 years after. So if this is the age of Theodore 3 years ago is represented by x minus 3, so you just substitute and that is equal. So age of Theodore 6 years ago is represented by x plus 6 divided by 2, so that would be the representation. And this is now our equation to represent this problem. So solve the equation. So we have to get rid of the fraction or denominator. So we have to multiply the LCD, which is 2. So 2 times x, then minus 2 times 3, then is equal to 2 times this given expression, x plus 6 all over 2. So to simplify, 2 times x is 2x, then negative 2 times 3 is negative 6. Then this expression times 2, 2 will be cancelled out. What is left is x plus 6. So solve the equation. So in the right side of the equation, there is x. In the left side, there is x. So conventionally, we used to gather the same variable at the left. By addition property of equality, transpose x to the other side. That would be negative x. Then copy 6. Transpose negative 6 to the other side. That would become positive 6. So further simplification, 2x minus 1x is just x. Then 6 plus 6 is equal to 12. So to verify that this is correct, so we have to check. So present age would be equal to his age, half of his age 6 years after. So if x is 12 minus 3, that would be 12 plus 6 over 2. So 12 minus 3, that is 9. Then 12 plus 6, that would be 18 divided by 2, and that is 9 is equal to 9. If we try to double check and put it in the table, since x represents the present age of Theodore, he is now 12 years old. So if he is now 12 years old, so 3 years ago, his age is 9 years old. 6 years after, his age would be 18 years old. So as you can see, his age 3 years ago is one half of his age 6 years after. So therefore, the present age of Theodore is 12 years old. Example number 4. It took 6 hours for Danny to clean the attic while Piolo took 12 hours to do the same job. If Danny and Piolo will work together, how long will it take to complete the job? So in this case, as the problem is asking for the time, which is in terms of hours, spent by Danny and Piolo to complete the same job working together. So in that case, we'll let that time as T. So T to represent the time spent by Danny and Piolo to complete the job by working together. So we are going to devise a plan. We are going to translate the given problem into an equation. So let us refresh that the work will be obtained by having the rate times the time, or basically the formula for work is equal to rate times time. So if we'll be looking for the rate, so we just divide both sides of the equation by time. So therefore, so rate is, so work divided by time, or that is W over T. Another techniques in solving word problem, particularly work problem, we will make a table. So in this case, in the first column, these are the persons, Danny and Piolo, and if they are working together. We represent the same job as, or the one job as 1. So the time spent for Danny to complete the job, it took him 6 hours to complete the job. The rate of Danny is in completing that particular job based from the formula rate is work over time. So that would be 1 over 6. So for Piolo, in working the same job, it took him 12 hours to complete the job. So therefore, his rate is 1 over 12. So working together, how many hours do they take to complete the job? Since we did not know, and we let that one as X. So therefore, their rate to complete the same job would be 1 over X. In making an equation, the rate of Danny plus the rate of Piolo in working this job is equal to their rate working together. So if the rate of Danny is 1 over 6, substitute, then the rate of Piolo is 1 over 12. That would be equal to 1 over X. There we have now the equation that will represent the condition of the problem. Our equation consists of irrational expression, so we have to get rid of the denominator. So to have the LCD of 6, 12, and X, so we have to do the prime factorization. The factor of 6 is 2 times 3. The prime factor of 12 is 2 times 2 times 3. Okay, the factor of X, oh, we just copy X. So those common factors, write them as 1. So bring down 2, bring down 2, bring down 3, because they are just 1. And bring down X. So multiply them. So the LCD is 12X. So we have to multiply both sides of the equation by 12X. So 12X times 1 over 6 plus 12X times 1 over 12 then is equal to 12X times 1 over X. So 12 and 6 have common factor, which is 6. So remove the common factor. 12 divided by 6 would be 2. Then 12 and 12 are also common, so we can cancel them out because their quotient is equal to 1. Then x and x is also common. So multiply what is left. So 2x times 1 is 2x. Then x times 1 is x. Then 12 times 1 is 12. So simplify. 2x plus x is equal to 3x. Then it is equal to 12. Solve for x. Divide by 3 both sides. So x is equal to 4. So to check that this is correct, so again, we have to substitute it to the condition if they are equal. So 1 over 6 plus 1 over 12 is equal to 1 over 4. Simplify the left side of the equation. So the LCD is 12, so we have to multiply 6 by 2 to make it 12. So 6 times 2 is 12, so we have to multiply the same constant on the numerator. Okay, so this is 12 already. We just copy the common denominator, which is 12. So 1 times 2 is 2 plus 1 times 1 is 1. And that is equal to 1 over 4. So further simplification, 2 plus 1 is 3. Then 3 divided by 12 in the lowest term, that is 1/4. So as you can see, it makes the both side of the equation equal. So since the condition is satisfied, therefore it takes 4 hours for both of them to complete the same job. Sample number 5. Meggy won the 2-day bicycle race. He traveled 60 kilometers each day, and his average speed on the second day was double that of the first day. So if Meggy rode for the total of 6 hours, so what was his average speed each day? So in this case, the problem is asking for the daily average speed of Meggy. We will let x to represent the average speed for the first day or of each day. Make an equation. So the distance formula is equal to rate times time. So again, it is asking for the rate. So we have to derive this formula. So by dividing both sides of the equation by time, the rate is equal to distance over time. In working with age problem, with work problem, distance problem, it is advisable that we will make or we will use a table to visualize the problem. Okay, so the distance is fixed because in the first day, Meggy is traveling 60 kilometers. Same goes on the second day. So the rate we did not know, so we let it at x. To represent the time of Meggy travels is so 60 over x. And day 2, still the distance is 60 kilometer, but the rate in the second day was doubled. So to double the rate on the first day, we just multiply it by 2. So therefore, his time in the second day, given that his rate is doubled, is 60 over 2x. So the total time traveled, Meggy, is 6 hours, both on the first day and the second day. So how are we going to make an equation? So time travel in day 1 plus time travel in day 2 is equal to the total time travels in day 1 and day 2, that is 6 hours. The first time is 60 over x plus 60 over 2x, and that is equal to 6 hours. So we have now the equation. So we will now solve this equation. So we have to get rid of the denominator. So the LCD would be 2x. So 2x times 60 over x is equal to 2x times 6. Then cancel out x, cancel out 2x. So simplify. So 2 times 60 is 120. Then 2x divided by 2x is already 1. So we just copy positive 60. Then is equal to 2x times 6, and that is 12x. So further simplification. So 120 plus 60 is equal to 180. And that is equal to 12x. So divide 12 both sides of the equation to solve for x. So x is equal to 15. So we are going to check whether this value satisfies the given condition. So if x is equal to 15, substitute. So 15. So 60 divided by 15 is 4. Then 60, copy. 2 times 15 is 30, and that is equal to 6. 60 divided by 30, that is 2. And 4 plus 2, that is 6. So as we can see, the value of x, or the rate, which is 15 kilometers, satisfies the given condition. To check it, so we have to go back to the table. So if x is equal to 15 kilometers, so 60 divided by x, so that is 4 hours. So if its rate is double, so his speed on the, his rate on the second day is 30 kilometer per hour. So the time he traveled on that second day is 2 hours. So the total hours he traveled still 6 hours. So since the condition is satisfied, therefore the average daily speed is 15 kilometer per hour.
If you like this video, don't forget to hit the subscribe button, and in the comment section, kindly send me your thoughts and questions about this video and how could I possibly help you learn math lessons in an easy way.